So let's continue our problems from high tier. That's actually sort of challenging problems in GCSE and iGCSE level. So here you need to find OD. So that's actually the distance from point O to D. You're given a rectangle ABCD and you have some point somewhere so that you have corresponding distance to each vertex, like 4, 5, and 3 centimeters, okay? And here you need to find x, so distance from O to D. Okay, so let's try to, first of all, pause the video and try to do by your own, okay? And I'll try to give my explanation. Okay. In order to do this, I guess we need to put heights, because otherwise we are not be able to find actually OD as a distance, because there is no basis to do. Okay, so that's why I input new letters and new heights. So actually what I want to do, I just want to split this area within a rectangle on different right angle triangles. For example, if I split, put in this line, and I mark the length, corresponding length, I say that will be A, that will be B, and that will be, let's say, C, okay? So here, I'll also put the line. This is height, right, from apex O to the opposite side BC. So let's say, because it's A, also A, okay, I'll mark as A and put it bottom to the bottom, means here, so that will be C. And now I also put 2 perpendicular here. That's 1. Oh, that's okay. That's 1, the last one that I required. So actually, I can also mark this as A, and the only I need is, I think, D, right? So this, from point B up to this point, is going to be D as distance. Okay, so for example, this letter K, this letter, let's say N, this letter, say P, and this letter, say, okay, R. But instead of letters, I'll just use lenses immediately in order to figure out, in order to complete Pythagoras theorem, Pythagoras equation for each triangle. Okay, so now let's get started and consider the first. So what I'm going to do, my purpose is to complete several equations and to see how which sort of simultaneous equation I will have. Okay, so that's why I'll be writing each triangle and trying to write corresponding Pythagoras theorem applicable to it. Okay, I started doing like this. So I mark triangles like this is the first. So 4 squared, yeah. Let's say this is the second one. This is the third one. It contains actually x as hypotenuse, right? And let's say this is the fourth one. Okay. So I also put D here, and C I'll put here, okay? So let's complete several equations. So triangle 1, I triangle B, P, O. So from here I can figure out that 4 squared equals to A squared plus D squared, okay? A squared plus D squared, okay? So second triangle, triangle KOC, it's here. So I complete 3, this is height, right? 3 squared equals to A squared plus B squared, okay? Because this also B. Okay, so third triangle, well, actually X we need to find. So that's triangle here, and we express X through B and C. So triangle CRD. So from here I can figure out that's x squared, the side that we're looking for, or distance that we're looking for, equals to b squared plus c squared. Okay, and the last one is triangle number 4. It's here. So triangle A, so point O is here, so AON. Okay, let's complete Pythagoras for it. So 5 squared equals to c squared plus d squared. Okay, so I'll figure out that actually this is all possible equations that we complete. Okay, so first of all, let's count how many variables. So A, D, B, C. So they're actually 4 variables and x the 5th one. Yeah, I know that we have only 4 equations, but let's see, maybe there is a chance that 2 variables will be considered as 1, and that will help us. Okay, so what we can do, let's start straight away from x squared equals b squared plus c squared. So actually it's good way if we express b and c through other variables. So from here, for example, b, I just highlight the variables that we want to express first. And so b squared is already here, while c squared is in the bottom part. Okay, it's here. So from here, we can say that b squared is 9 minus a squared. So from here, we can figure out that c squared is 25 minus d squared. Okay, what we need to add them up, right? Because we want to have b squared plus c squared. Okay, so let's do it. So we add them up, add those 2 equations in order to get a b squared plus c squared. So if we plug that, we'll get 9 plus 25, which is 34, and here we'll get minus a squared and minus d squared, but I will write like this. Okay, I factorize minus 1 as the common factor. Okay, so we don't need those equations anymore. Okay, so that's why we use them. I can cross them out. Okay, now we're left with a squared plus d squared. Where we have it already here, so we just simply can plug 16 instead. You see, that's what I told you. Actually, there were 5 variables, but a squared plus d squared we will consider as a single one. So that's actually 16, and we got the following. So 34 minus 16. Okay, so let's finally calculate x squared. So x squared is, so 24 is 18, and now we just take in the square root of it. So square root of 18, which is, I say 9 times 2, so 3 square root of 2. So I simplify this third, so we actually have insert notation. Okay, that's how it was found. So one more time, we actually apply Pythagoras theorem to each triangle, and we saw them like 4 different triangles. Of course, they're repeating in the whole rectangle, but actually, this is the way how we can use that. Okay, so hope you did the same. That was challenging task. That's sort of higher tier, less questions, but it's less likely that you will need on exams. This is just to extend your understanding of Pythagoras, maybe geometry. Anyway, this stuff you will need to have as the required tool for your IB diploma for your A-levels. So trust me, this is the truth. Okay, so keep practicing, keep trying to find like hardest task, challenging task in GCSE, iGCSE level, so and try to go through. Okay, thank you, hope you enjoy, and see you.